When we have an exponential expression of the form a to the power of log b to base a, then it can be simplified to just b. In other words, the base of the exponential is the same as the base of the logarithm in its index. Why is that so? You can consider letting x equals to the exponential expression, then apply log of base a to both sides of the equation. We can apply power law to bring down the power of log b base a to the front of the logarithm. Since log a base a is equal to 1, the right hand side of the equation is just log b base a. Then by the equality of logarithms, x is equal to b, hence the exponential expression can be simplified to just b. Here are some examples. In example 1, the base of the exponential is 10, which is the same as the base of the common logarithm in the index. So this exponential expression can be simplified to just 7. In example 2, the base of the exponential is e, which is the same as the base of the natural logarithm in the index. So this exponential expression can be simplified to just 5. There are times where we need to apply the laws of the logarithms such that we have only a single logarithmic term in the index with coefficient of 1, as shown in example 3. When compare the exponential expression in example 3 with what is being stated above, we need to do something about the 2. So here we can apply the power law so that we have the logarithmic term in the index to be of coefficient 1. Hence, since the base of the exponential is 2, which is the same as the base of the logarithm in the index, we will be able to simplify this exponential expression to just 4 squared, which is 16.